Hello everyone. Today we are going to learn about shortest remaining times for scheduling or like SRTF in operating systems. So see, definition is SRTF is the primitive version of ESJF, shortest job first. So in this scheduling the process with the shortest remaining burst time is executed next. If a new process arrives with a shorter burst time than the remaining time of the current process, so the CPU is preempted and given to the new process. See, here is imagine a hospital, okay? So patients are waiting for treatment. So if the first patient needs 30 minutes, but the next patient needs only 5 minutes, okay? So treating the first patient first means the short patient waits unnecessarily. So the total waiting time is higher, okay? Total waiting time is higher. Waiting time is higher, okay? So so SRTF scheduling works like a smart doctor. It always chooses the patient or process that can finish quickly first. So in terms of OS, the CPU always picks the process with the shortest remaining burst time. Okay. So like actually what does primitive mean? Okay. See. See. Key points. SRTF is primitive unlike SJF. Always chooses the process with the minimum remaining execution time at any given time. Reduces average waiting time more efficiently than FCFS and even non-preemptive SJF. May cause starvation for long process if short process keep arriving. See, so what does preemptive mean? What does preemptive mean? Okay, basically this means if a process is running and new process arrives with a smaller remaining time, so the actual CPU stops the current process and executes the new one. Okay, so basically preemption is like a pause button. You temporarily stops the current task to handle a more urgent and shorter task. So this helps reduce average waiting time. Okay, clear? So burst time means total CPU time a process needs to finish, and remaining time means how much CPU time is left for the process. Okay. So instead of just looking at total time, SRTF looks at what is left for each process. Okay, so the CPU always picks the process that has the least remaining work. Okay, now see why like SRTF is better than FCFS and SJF. Like FCFS executes in arrival order, okay, ignoring burst time. This can make short process wait a long time behind like big ones, and SJF executes the shortest job first, but non-preemptive SJF cannot stop a long running process. So like SRTF improves efficiency here because it can interrupt a long process if a shorter one arrives. Okay, like SRTF tries to minimize waiting time dynamically, unlike other algorithms that are static. Okay, now see, here is example. So let's take four process P1, P2, P3, P4. See, one is first step is time 0. Okay, time 0. Only P1 is present. Okay, so CPU starts P1. Okay, so meaning no other choice yet. Okay, steps 1. Then steps 2, time 1, P2 arrives. So P1 has 7 left. Okay. Okay, so P2 needs 4. So P2 shorter, so CPU switches to P2. Okay. Okay, then so like shorter tasks get priority to reduce total waiting. Okay, then time 2, time 1, now time 2. Okay, then P3 arrives. So remaining P2 is 3 and P3 is 2. So CPU switches to P3. Okay, so like always pick the job that can finish fastest. Okay, then time 3, P4 arrives. So remaining P3 is 1, P4 is 1. So it is like tie. So continue P3 because it started earlier. So finishes at 4. Okay. Okay. Now see. Now see. So basically execution order is like P1, then P2, then P3, then P4, then P2, then P1. Okay. So meaning is like CPU always dynamically adjust based on which process can finish fastest right now. Okay. Now see. So here is at time 0 only P1 has arrived. So the CPU starts with P1. Okay. At time 1 P2 arrives. Remaining time of P1 is 7. So P2 burst is 4. So since P2 is shorter, the CPU switches to P1, P2. Okay. And at time 2 P3 arrives. Okay, remaining time of P2 is 3. So P3 burst is 2. So P3 is shorter. So CPU switches to P3. And at time 3 P4 arrives. So remaining time of P3 is 1. So P4 burst is 1. Both are like equal. So the process that started earlier P3 continues and finishes at time 4. Okay. Okay. So next is P4 executes from 4 to 5. After P4, P2 resumes from 5 to 8. And finally P1 resumes from 8 to 15. Okay. Okay. So execution order with preemption is P1, then P2, then P3, 2, P4, then P2, then P1. Okay. See, calculating metrics. First is completion time CT. So the time when a process finish. Then turnaround time TAT. Total time from arrival to completion. CT minus arrival time. Then waiting time. Time spent waiting in the ready queue. TAT minus burst time. Okay. Now here is like, see, Basically completion time means total real time taken to finish including waiting. Okay, and turnaround time, total time process spent in the system from arrival to finish. And in waiting time, time process actually spent waiting, not like executing. Okay, so line by line results are here, like see P1, so CT is 15 tat 15 WT is 7. Then P2, CT is 8, tat is 7, WT is 3. P3, in P3 CT is 4, tat 2, WT is 0. P4 CT5, tat 2, WT 1. Like short processes like P3 and P4 waits very little. P3 and P4 waits very little. Okay, and long process wait more, like P1, P2, long. Okay, now see advantages. Minimize average waiting time better than FCFS and SJF. Efficient for CPU bound processes with varying burst times. Disadvantages: requires exact knowledge of burst times, which is often difficult in real systems. Long process may experience starvation if short process keep arriving. Preemptions may increase context switching overhead. See, basically advantages is reduces average waiting time, so short process finish quickly. Okay, so efficient CPU utilization means less idle time. Okay, and now disadvantages, it's like needs exact burst times, so hard in real systems. Okay, and can cause starvation, so long process may wait uh, indefinitely. Okay, so more context switching, slight overhead. Okay, so meaning is like SRTF is efficient but needs careful management in real operating system. Okay, see conclusion, SRTF is the preemptive form of SJF, always executes the process with the shortest remaining time. It is efficient but can cause starvation, so in real systems it is combined with techniques like agile to prevent long process from waiting forever. SRTF means preemptive SJF, so always executes the process with shortest remaining time, so reduces waiting time but may cause starvation. And agile or other techniques can prevent starvation in real OS. So basically this algorithm is smart. Okay, because it dynamically adapts to the current situation to improve performance instead of blindly following arrival order or fixed rules. Okay.